Hey friends, welcome to my channel, and this video is going to be very important because in this video I will discuss four important examples of the Birch reduction, and all of these reactions are very important and interesting. There are high probability of coming in the csir-net exam, so you should watch this video till the end. So the first and one thing I should mention is that I have already a video on the Birch reduction, the basic concept of the Birch reduction, the basic mechanisms. You can watch that video. In this video I will not discuss about the basic mechanism, but I will discuss only the problem. So if you are uncomfortable, you can go to that video. I will put the link of the video on the description section. So you can see this is the problem given. This molecule is given, and it is reacted in the condition lithium liquid ammonia, and the second in the second step it is given ammonium chloride. So what will be the product? Now one thing you should note is that whenever you have only liquid ammonia and lithium, then what will be the reaction outcome? If you have ethanol in your reaction medium, the outcome will be completely different. So in this case only lithium and liquid ammonia is given. Now for the Birch reduction of benzene ring generally requires a proton source, for example ethanol, but in this case you can see only lithium and liquid ammonia given. Now it is not like that only with lithium and liquid ammonia Birch reduction of benzene will not take place. It will take place, but the reaction rate is very slower. Now in this case you can see there are two centers which can undergo Birch reduction. One is this aromatic ring and another one is this enone. Because enone systems, if you have a enone system, then also the Birch reduction condition can reduce this double bond and you get this product. Now in this case again there is two condition. If you use only liquid ammonia and lithium condition, then you will get this product, whereas if you have ethanol in your medium, you will get this one, that is both the CC double bond and the CO double bond both are reduced in this case. Now in this case you can see only lithium and liquid ammonia is given, no ethanol is there. So that means this double bond will only be reduced. Now so the basic concept behind this problem is that the reduction of benzene ring is slower in only lithium and liquid ammonia condition. It needs ethanol, and as ethanol is not there, so this ring will be unaffected. So it will be as it is, only the double bond is reduced, and in this case the reduction is stereo selective, that is you will get only one product, and the product is, that is this hydrogen will be upward and this will be lower. So now how this stereochemistry comes, that is beyond the scope of this video. I cannot explain that. You have to know that this will be product. Now I don't think if this question comes in exam they will ask you the stereochemistry. They will give you some option which has only this stereochemistry, because to remember that where the hydrogen will what will be the stereochemistry of the hydrogen, it is really difficult. So the thing which you have to remember from this problem is that in this particular condition the benzene ring will be unaffected and only the CC double bond will be reduced. Now for example, if they change the condition, that is if they give here ethanol, then what will happen? So then the reaction outcome will be completely different. Then your benzene ring will also be reduced, and as a final product you can either get this one, and in this case this will also be reduced. So what will be the stereochemistry, I don't know, it is not mentioned in the book. So here it will basically reduce. So this product you can get, or this double bond may be in this side. So when the ethanol is there, okay, so if ethanol is there, so this little difference you have to remember, because in the exam they can either give you with ethanol or they can give you without ethanol. So what will be the product, that you have to tell. So this is our first problem. Now I will discuss the next problem. So this is another very good example, as you can see. So in this case this particular compound is reduced, but in this case you can see ethanol is there. So these two products are obtained in this case. Now what you have to remember from this problem is that, so basically you can see this enone is reduced fully because ethanol is there. So due to the presence of the ethanol, both this CC double bond and CO double bond both are reduced, and most important part of this reaction is that you can see this double bond is in conjugation with this benzene ring, and due to this conjugation this double bond is also reduced. So if you have a isolated double bond in your in your compound, and if you react it with Birch reduction condition, it will never be reduced. But here you can see it is in conjugation with the benzene ring, and due to this conjugation it is also reduced. Now another very noticeable point of this reaction is that only these two isomers are obtained from this particular reaction, but if you just revert one or other stereo centers of this compound, you can get a combination of, for this molecule you can get 16 isomer, and for this molecule you can get 64 isomers. So out of these 16 and 64, that means total of 80 isomers are possible for these compounds, different combination of the groups, but only these two are obtained. So this is a very remarkable reaction. This shows that how much the stereo selectivity and the regio selectivity of Birch reduction is. So you don't have to remember that what is the stereo centers. What you have to remember from this problem is that both of this CC double bond and CO double bonds are reduced, and in this case this conjugation is also not there in the final product. So this thing you have to remember. Now this is one problem. Now I will discuss another two problems, and they are also very important. So this is again a very important problem. You can see there are two double bonds, and regio selectively and stereo selectively only this double bond is reducing in this particular case, and you can see it is again lithium liquid ammonia condition, no ethanol is there, so this CO double bond will be unaffected. Now why this particular double bond is regio selectively and stereo selectively undergoing reduction in this case? So for that you have to first draw the exact chair form of the molecule. So you can see this is the chair form of the molecule. So here you have another ring. Okay, now you can see this is two double bonds, and here you can see this is your methyl group and this is your OH group. Now in the first step, when the two lithium ions will give electron in the center, it will form the enolate. Okay, so here you will have a negative charge, and another negative charge will be delocalized over here. So both of these two centers are negatively charged. Both of them can take proton, but you can see the stereochemistry of this compound is or this intermediate is such that only this center can undergo protonation, because there is no ethanol molecule present in the molecule. So only this OH is available. This proton can be taken, and that can be taken by this center only. This is far from this OH, and that's why it cannot take. So if it take the proton, what you will get is, here you have OH, so basically it will be now O minus, and here you have methyl group, and here you have this enolate over here. So this double bond is intact, and now when you put NH4Cl, it will take proton from this side, and that will basically give you this proton. So you can see the side which is nearer to this oxygen, that is only reduced, and in this case you can see this particular double bond is nearer to oxygen, and that's why it is undergoing the reduction. So this is a very important problem. And the final question now which I am going to discuss is, so this is the final problem, and you can see in this case again only the lithium and liquid ammonia is given, no ethanol is given, so this carbonyl group will be unaffected here. So in the first step you will have this electron. I am writing 2 electron in a single step, and that will give you the enolate. So basically this enolate you will have in the first step. So double benzene ring will also be unaffected because ethanol is not there. Now the stereochemistry in the center is undetermined. Here you have minus, and here you have phenyl. Okay, so this is the first step. Now after so it can also take proton from the ammonia molecule, and if it take proton from the ammonia molecule, So actually it is like this. Okay, so if it take proton from ammonia molecule, it will have a hydrogen and a phenyl, but the stereochemistry is still undetermined at this particular center. Now in the final step, when you are giving ammonium chloride, now this center will undergo protonation, and here you have one R group also. So now it will undergo protonation, and the product which is obtained in this case is this one. So you will have both the R group and the phenyl group there in the same site. That is, the protonation is taking place in this case. What is observed is that you can see the hydrogen is coming from the same site where this hydrogen is. So that means while the protonation is taking place, it follows the phase which is sterically less inert, and this is the case for this compound. But if you do the same protonation step in ethanol medium, so instead of ammonium chloride, if you just give ethanol, so you are not giving ethanol in this particular step, because if you give ethanol from the beginning of the reaction, then your carbonyl group will also be affected. So first you are removing all the lithium from your reaction medium. You are just before workup you are giving ethanol. So in this case, basically the giving ethanol means only you are doing the protonation step slower, that is reversible, and if that you do, then you will get completely different outcome. So in this case you will get this R group below and pH group above. So that means in this case the more stable trans product is obtained. So basically when you are doing the reaction in ethanol, it is thermodynamically controlled and slow reaction, so that's why you are getting thermodynamically more stable product. So basically in both cases you will get a mixture of these two, but when the reaction is taking place without ethanol and you are doing the final workup with ammonium chloride, you are getting this as major due to the irreversible and irreversible fast protonation and kinetically controlled product. And while you are doing the reaction with ethanol, then you are getting this as major because of the slow and thermodynamically controlled product. So these four examples are very important, and you should definitely check out these examples before your exam. And also I put the PDF file of this in the website. I will put the link in the description section, you can check. Thank you for watching, and don't forget to subscribe my channel.